Hello everyone, today we'll be looking at some quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2019 Test 3A Paper 1 Code C and D. So let's start with the first section. This section contains 6 questions. Each question has 4 options out of which only one single option is correct. So let's start with question number 21. Debromination of vicinal dibromides takes place when allowed to react with zinc alcohol. Consider the reaction given below. So students, we have been given this substrate and it is allowed to undergo debromination using the given reagent, and we have to comment on the major product which is obtained during the reaction. Now students, if we talk about this reagent, it causes E2 elimination. So in E2 elimination, the elimination takes place in an anti-fashion. So let us first try and convert this structure which is given to us in the wedge dash form to the sawhorse projection. So we know that in the sawhorse projection we have to draw two Y's. Now, if you talk about the location of the groups, we'll be standing here on the plane of the paper and we'll be looking along this direction, along this bond. So if you talk about the first carbon will be here and we'll have bromine at the bottom. Then we'll have pH on the right and we'll have H on the left. If you talk about the second carbon, which is denoted at this position, similarly we have Br at the bottom again, and this time on the right we're going to have pH. And on the left we are going to have H again. So students, this is the conformation in which the Br and the Br are eclipsed. We need the conformer in which the Br and the Br are anti. So we can rotate any one of these carbons. The relative configuration will not change as we are already dealing in the 3D projection. So this Br now comes at the top and we'll have the pH on the left now and we'll have this H on the right. Now when zinc attacks this Br, this bond shifts here and this Br leaves. So what we're going to have is, we're going to have this pH and this pH. They will be in a trans fashion in the alkene which is formed. So we're going to have H, pH, pH and H. So we're going to have the formation of a trans alkene in this case. So if you look at the options which are given to us, we can clearly see that we have to select option B as the correct answer to question number 21. Let us look at the next question. Question number 22. In the given reaction, so we have been given two reaction 1 and reaction 2, and the examiner seems to be interested in the products P1 and P2 which are formed during the reaction. So if we talk about the first reaction, the first reaction involves a ketone and it is allowed to react with the acidic medium. So what happens is, this lone pairs over oxygen will attack this proton and will get protonated. So this is an example of acid catalyzed tautomerism reaction, students. So in the next step, what is going to happen is, the pi bond will shift and we are going to have the formation of this intermediate. In the next step, we're going to have a methyl shift. Which is the rearrangement step of the carbocation. And in the last step, we are going to have the loss of a proton, because in that case, we'll have aromaticity in the structure. So this is the major product P1 which is formed in the reaction 1. Now if you look at the second reaction is an example of semi-pinacol rearrangement. So in this reaction, NaNO2HCl. The NaNO2HCl will convert this amine into N2 plus and it will just leave, leading to the formation of a carbocation. So we're going to have the formation of this structure. And in the next step, any one of these two methyl groups will migrate on this carbon, leading to the formation of a more stable intermediate. As the carbocation can now be stabilized by the lone pairs over oxygen. So this will eventually lead to the formation of a ketone. So we are going to have the formation of this structure. So students, this is the major product P2 which is formed in the reaction. Now if you look at the options which are given to us, we can clearly see that we have to mark option D as the correct answer to this question. Let us look at the next question. Question number 23. Consider the following reaction of alkyl benzene. So we have been given a reaction in which a substituted benzene is allowed to undergo nitration reaction. So we have the products in which the nitration takes place at the ortho and the para position. And regarding these groups, the examiner tells us that Y can be any one of these given alkyl groups, and he is interested in the correct percentage of ortho product which is formed if the alkyl group on the benzene ring is changed accordingly. So students, if we talk about the alkyl groups which are given to us, we can clearly see that as we move from 1 to 4, the bulkiness of the attached group on benzene ring increases. Now, if the group attached on the benzene ring is bulky, the percentage of ortho product will decrease because it will create a steric hindrance to the attack of the incoming electrophile. So we can see that if Y is a tertiary butyl group, the substitution at ortho position will be difficult as compared to if the Y is a methyl group, which is very much smaller in size than the tertiary butyl group. So students, as we move from 1 to 4, the size of the alkyl group increases, and hence the percentage of the ortho substitution product decreases. So we're going to have the maximum ortho substitution in 1, followed by 2, followed by 3, and followed by 4. So if you look at the options which are given to us, we can clearly see that we have to select option A as the correct answer to this question. Let us look at the next question. Question number 24. In the given reaction, so we have been given benzyl, it is allowed to react with the basic medium to form the product. And the examiner seems to be interested in the type of functional groups which are present in the product. So students, the given set of reagents will cause benzylic acid rearrangement. So we can talk about that rearrangement. So we have benzyl. It is allowed to react with OH minus. So students, what is going to happen is this OH minus will attack this carbonyl carbon, any one of these two carbonyl carbon as they are both similar, which will lead to the formation of a tetrahedral intermediate. So we're going to have this intermediate. Now, when this negative charge comes back, one group has to leave. So it will be the pH in this case. So this pH group will leave and it will attack the adjacent carbonyl carbon. So what is going to happen is there will be the formation of a tetrahedral intermediate at the other carbon, whereas this group will be converted into an acid. Now students, what is going to happen is there will be intramolecular proton transfer where this hydrogen will be transferred to this alkoxide group. So we are going to have the formation of this structure. So this is the final product which is formed in the basic medium. The H will not be protonated in this case, as carboxylic acids are quite acidic. So if we look at the functional group which are present in this product, we can find a carboxylate ion and we can also see an alcohol group present. So students, if we look at the options which are given to us, we can clearly see that we have to mark option D as the correct choice to this question. Let us look at the next question. Question number 25. Consider the monohalogenation of butanone carried out in the acidic and the basic medium as follows. So the examiner has given us a reaction in which the monohalogenation of butanone is carried out once in the acidic medium to lead to the formation of P, and the halogenation is carried out in the basic medium leading to the formation of the product mixture, which is Q. So the examiner seems to be interested in the product mixture P and Q. So let's try and figure out the products P and Q. So if we talk about the first reaction in which the halogenation takes place in the acidic medium, so we have butanone which is reacting with Br2 in presence of H+. Students, the halogenation in this case takes place via the enol formation. So if we talk about the two possibilities of the enol which are going to be formed in this case, we have these two enols and we can have another enol. Now if we talk about the two enols which are formed, we can clearly see that this enol is more stable and the attack on the halogen will take place via this enol itself. So in this case, we are going to have the formation of the monohalogenated product in which the Br is substituted at this position. We can also talk about the mechanism. The lone pairs over oxygen will be involved in resonance and the carbon ion will be generated here, which will attack the Br2 molecule, causing a substitution at this carbon. So we are going to have the formation of CH3, CHBr, CO and CH3. So this is the major product obtained in the product mixture which is P. If we talk about the base catalyzed halogenation in the next case, we have butanone again and it is allowed to undergo halogenation in presence of the basic medium. Now, this OH minus can attack any of these two acidic hydrogens. So there is a possibility of attacking at the terminal hydrogen and at the non-terminal hydrogen as well. We're going to have the formation of enols again. And if the attack happens on the carbon at the right, so we're going to have the formation of this enolate ion. Now, what happens is these two hydrogens indicated are almost equally reactive to the attack of the nucleophile. So what happens is both of these two species will be present in almost similar amounts in the reaction mixture, and the attack can happen via any of these two intermediates, leading to products which have the bromine substituted at any of these two positions. So we're going to have the monohalogenation happening at either the third carbon, or we can have the monohalogenation happening at the first carbon. So we're going to have the products which are shown in almost equal amounts. So if you look at the options which are given to us now, we have statement 1 saying product mixture Q contain both 1 bromobutanone and 3 bromobutanone in virtually equal amounts. This statement is correct, students. We had already seen that both of them will be formed in almost similar amounts. If you look at statement 2 which is given to us, product mixture P contains 1 bromobutane 2-one in major amount. Students, this statement is incorrect. We've seen that the monohalogenation in the acidic medium leads to the formation of 3 bromobutane 2-one. So the second statement is incorrect. Let us look at statement 3 now. When 1 bromobutane 2-one is monohalogenated by Br2 in the basic medium, then 1,1-dibromobutane 2-one is formed. So if you look at the product which is mentioned to us, the examiner seems to be interested in 1 bromobutane 2-one, and he is interested in the further monohalogenation of the structure. Now, if we talk about the halogenation in the basic medium, the OH minus now has again two options. It can either extract this hydrogen or this hydrogen. Now, what happens is, students, due to presence of this Br, which exerts a minus I, this hydrogen will be more reactive and the second bromination will happen at this position itself. So we're going to have the formation of 1,1-dibromobutane 2-one. So if you look at the statement 3 now, we can see that the statement given to us is correct. Let us look at statement 4 now. In base catalyzed halogenation, the first bromination will occur faster, but substitution of another hydrogen by bromine is slower. This statement is incorrect, students. We had seen that the carbon ion will be more readily formed in the second halogenation because of the presence of Br group, which exerts a minus I effect on the carbon ion. So we have seen that statement 1 and statement 3 are correct. So the examiner seems to be interested in the correct statements. So we have to select option A as the correct answer to this question. Let us look at the next question. Question number 26. The specific rotations of an alpha and beta forms of a derivative of glucopyranose are plus 110 degree and plus 20 degree respectively. If an equilibrium mixture of these two anomeric forms has a specific rotation of plus 60.5, then the percentage of alpha and the beta forms in the mixture are respectively. Students, this is a very simple question. So we have the alpha form and the beta form. The alpha form has a specific rotation of plus 110, whereas the beta form has a specific rotation of plus 20. Now what happens is, if the contribution of the alpha form is assumed to be x, then the contribution of the beta form will automatically be 100 minus x. So we have the equation 110 into x plus 20 into 100 minus x is equal to 60.5 into 100. So this 100 is because we are dealing in percentage now and not the fractions. So if we simplify the expression, we are going to have 90x plus 2000 giving us 6050. So we have 90x is equal to 4050, which on solving gives us a value of x equal to 45. So the percentage of alpha form is 45% and the percentage of the beta form is 55%. And if you look at the options which are given to us, we have to mark option C as the correct answer to question number 26. Let us look at the next section.